Okay, let's do one more confounding example for good measure. So, once again, we have our treatment A. We can think of this as a heart transplant once again. We can look at survival time Y. I've put them close together. You must think I'm going to actually connect them, but nay. We can think of Y being survival time. So our outcome of interest is survival time. Once again, we'll have some sort of measured confounder or just sort of measured variable here. This measured variable will be some sort of test for cancer. Okay? And then finally, we're going to have U being cancer itself. So in this case, cancer itself, it sounds devastating. And it is, truly is. The idea is this is whether the patient truly does have cancer. So of course, whether the patient truly does have cancer affects the cancer test, but the cancer test is not 100% reliable. Whether the patient actually has cancer or not is actually going to go ahead and affect whether they go to treatment, because this will induce symptoms that will make them more likely to get this transplant. And then finally, whether they have cancer or not is going to affect their outcome, survival time. So it's pretty terrible. Okay, again, I'm going to go ahead and condition upon L. So question, are A and Y associated? So the answer is, well, let's check it out. So we have some A, the treatment, heart transplant. This is affected by some unmeasured cofounder or confounder, which is U. U goes ahead and it affects Y in this case. And ta-da, they are linked, so they are associated. So why did we even condition upon L in the first place? Well, L is not necessarily 100% truthful in that it can often, well, it can sometimes say that they don't have cancer when they do have cancer, but it is quite related to the fact that they do have cancer. So we call L actually a surrogate. We call L a surrogate confounder. The idea behind it is that yes, we cannot capture all of the confounding nature of U, our unmeasured variable, whether they truly do have cancer or not. That being said, the cancer test will capture a great deal of it. And even though A and Y, so even though the treatment and the outcome are associated, even if they don't have a causal effect, this association should hopefully be weak because we've conditioned upon this surrogate confounder. So yes, it's good, it's not the best, but it's the best that we can often do in many cases. So this will be the last of my confounding examples. I hope they've not been too confounding for you. And we'll be moving on to selection bias. And then I can go ahead and sum this all up and tell us why have we been studying this once again and show how we can use these tools in an observational study.